Welcome everyone. This video is part of Object Pascal Algorithms course, which you can find on Udemy platform. In this tutorial, we will be solving a common interview question related to linked lists. But I should mention that this also helps you to understand linked lists in general, and that will help you in real-world problem-solving cases. So we have already implemented our linked list class in previous tutorials. Alright. Now we will be using it to solve various problems or add more functionalities to the linked list class itself. The task we need to achieve is we have given the head of a single linked list. We need to return true if it's a palindrome or false otherwise. In general, it is easy to solve. Of course, it's easy one. But before really implementing the palindrome function itself, we need to reverse the linked list. That is a one function. And we need to also implement compare function to compare the lists. To solve a given problem using the linked list data structure in Delphi, we will first create a new function called isPalindrome inside the tLinkedList class. This is the function that I'm talking about. So this function will return a boolean indicating if the linked list is a palindrome or not. But we cannot just write our isPalindrome function. We need to handle the linked list data structure to reverse it and also compare them, What we're gonna do is we will implement reverse linked list function to reverse it, and also compare linked list or compare lists here to compare two lists by given head pointers. So this reverse linked list function is used in the isPalindrome function to reverse the second half of the input linked list so that we can compare the first and second halves to check if the linked list is a palindrome. Well, I don't want to take your time by typing these functions. I will just copy and paste it here and explain how it works. I think that would be much more efficient for you guys. So as you can see, it takes a node, t-node here, as its input parameter and returns a t-node again. The purpose of this function is to reverse a linked list starting from the given input node. So I'm going to jump into it. There we go. So we're declaring the three t-node variables: previous, current, next. These variables will be used to keep track of the previous, current, and next nodes while traversing and reversing the linked list. We're initializing previous to nil and setting the current to the given node here. Alright, and we're going to start a while loop that continues until current becomes nil. This loop iterates through the linked list. So inside the loop, we're going to set next to the next node of the current node, which is current.next here. This keeps track of the next node before we modify the current.next pointer. So we're here updating the next pointer of the current node to the point to the previous node. This is a step where we reverse the link direction for the current node. And then we can move the previous pointer to the current node, since the current node will become the previous node in the next iteration. And then we can move the current pointer to the next node in the original linked list by setting it to next, which is here. So at the end, when the loop finishes, previous will be pointing to the new head of the reversed linked list. And then we're gonna set the result to previous. Why? Because we need to return the head of the reversed linked list. So the next function we need to take care of is the compare lists. So it takes two nodes as input parameters, head 1 and head 2, both of type t-node. So the purpose of this function is to compare two linked lists starting from the given head nodes and return a boolean value indicating whether the two lists are identical or not. So I'm going to jump into it. We're going to start a while loop that continues as long as both head 1 and head 2 are not nil. This loop iterates through both linked lists simultaneously. So inside the loop here, we compare the data of the current nodes in both lists head1.data and head2.data. If the data is not equal, we're going to set the result to false and exit the loop. This means that two lists are not identical. If the data of the current nodes is equal, we can move both head1 and head2 pointers to their respective next nodes by updating them to head1 equals head1.next, which is the next data. And when the loop finishes, we check if both head1 and head2 are nil. If they are, means we have reached the end of both lists. And since the loop has not exceeded earlier due to a data mismatch, we can conclude that the lists are identical. And then we can set the result to true by evaluating the expression, which is head1 equals nil and head2 equals nil. The compare list function is used in the isPalindrome function to compare the first and the reverse second half of the input linked list. If the two halves are identical, it means the linked list is a palindrome. And now we need to use this reverse linked list and compare lists inside the isPalindrome function. Alright, now we are in the main final part, which is the implementation of isPalindrome function itself. I'm going to jump into it. Well, there we go. We're declaring a slow pointer, fast pointer, previous of slow pointer, mid node, second half variables, all typed in the T node here. These pointers will help us to find the middle of the linked list and split it into two halves for comparison. We are initializing slow pointer and fast pointer to head, and the set previous of slow pointer to nil. And we're saying that the result is true, which assumes the list is palindrome until proven. Alright, and we're checking if the head is not nil, which means we're checking if the list is not empty or not. And we are starting a while loop that continues as long as fast pointer is not nil here. This loop is used to find the middle of the linked list using the slow and a fast pointer technique. So inside the loop, we're moving a fast pointer 2 steps ahead and a slow pointer 1 step ahead. And we are updating previous of slow pointer to the value of slow pointer here before moving it ahead. The loop continues until fast pointer reaches the end of the list or becomes nil, right? So after the loop, we can check if fast pointer is not nil here. If true, this means the list has an odd number of elements and the mid node is set to slow pointer. And we can move slow pointer 1 step ahead. Slow pointer equals slow pointer dot next, and we can set second half to slow pointer here, which is the head of the second half of the linked list. And then we can set the next pointer of previous of slow pointer to nil here. Previous of slow pointer dot next equals nil. Effectively, this breaking the list into two halves. And then here, in the second half, we are reversing the second half linked list using reverse linked list function. There we go. And then here in the result main part here, we're comparing the first half starting from head and the reversed second half starting from second half. We just reversed it here. So if the two functions are equal, the function will return true, indicating that the list is a palindrome. Alright, so that's it. The isPalindrome function here checks if a given linked list is a palindrome by finding the middle of the list, reversing the second half, and comparing both halves at the end. I think now we can use this isPalindrome function in our main code. As you can see, we have my list, which is coming from T linked list here. Alright, we're creating a new linked list and adding ABBA values to the linked list and just using mylist.isPalindrome, and we're checking it. So I'm gonna save it and run. So the linked list is a palindrome. Alright, that's good because you can see the value here. If we add one element, for instance, now we have C. I'm gonna save it and run. Now it says the linked list is not a palindrome. So that's about it for this video. If you want to join our course, you can use the link in the description below, which has also the discount code. Thank you for watching.